Let f of x is equal to log x to the base c and g of x a rational function. Then we need to find the domain of the function f circle g, that is composite function. Let us consider the numerator part of the g of x, that is x power 4 minus 2x power 3, and here 3x square I can split up into 3 terms, x square plus x square plus x square, and minus 2x, and again 2 I can split up as 1 plus 1, so that I can regroup the terms x power 4 minus 2x power 3 plus x square, and again x square minus 2x plus 1, and the remaining terms are x square plus 1. So here I can take x square common, so that I can write x square minus 2x plus 1, and again here x square minus 2x plus 1, which is x minus 1 whole square, and x square plus 1. So here the three terms are here x square of x minus 1 whole square we can write, or x minus 1 whole square plus x square plus 1. Clearly we can say that the first term x square into x minus 1 whole square is always greater than or equals to 0 for any real number. It can be equal to 0 also. The second term, here we can say x minus 1 whole square the same way. For x is equal to 1, it will become equal to 0. So it can be greater than or equals to 0. And coming to the third term, x square plus 1, for any real number, x square plus 1 is always greater than 0. It cannot be equal to 0. So conclusion, we can say that the numerator part is greater than 0 of the function g of x. And now consider the denominator 2x square minus 2x plus 1. Let us find its nature of the roots. Comparing quadratic curve ax square plus bx plus c. Discriminant is b square minus 4ac. Let us consider. So minus 2 whole square minus 4 into 2 into 1, that is 4 minus 8, which is negative 4, less than 0. And hence we can say that there are no real roots, and since the coefficient of x square a is positive, so the curve will be open upward. So the curve 2x square minus 2x plus 1 is always positive. So we can say the denominator is also greater than 0. It cannot be equal to 0 also. So conclusion, the numerator, the g of x function, g of x, let us consider to be y, is equal to positive in the numerator and positive in the denominator. So we can say it is positive. G of x is equal to y positive. And also given f of x is equal to log x to the base c, and this function to be defined when x must be positive and the base e is anyhow greater than 0 and e is not equals to 1. So this function is defined for x is positive. And the composite function f circle g, let us consider f circle g of x. We can write it as f of g of x, which is equal to f of g of x as taken as y, which is positive value. F of y is equal to log y to the base e. And now this function is defined only for y is positive. But here we can say that y is positive for all real numbers. And hence we can say the domain of the function. So domain of the composite function f circle g is all real numbers, x belongs to R, which is option B.